Hi everyone, hope all are doing good, and I am here with a new video series which is going to be about industrial motor controls. And in that, I am going to first explain about the symbols and switches, and later we will see different motors and its control methods and related control circuits and wiring circuits. Yeah. So any motor controls will have basic components like switches, overload relays, contactors, and all those things. We must know what are the type of switches used or the sensors used, and what is the symbols represented in different standards. Like for example, we have a NEMA standards, IEC standards, so different standards, and then also we must know how it functions so that we can able to understand the control circuit diagram and then power circuit. Also we must know the basic concepts of the motor as well. Say for example, if you have a induction motor and then we have a wound rotor motor, both two different type of induction motors, how it differs from each other, a squirrel cage induction motor and the wound rotor motor. So if you know the basic difference between these two, then only you can able to understand why this is needed for the squirrel cage induction motor and why this is needed for the wound rotor motor. And similarly, synchronous motor, if you take a synchronous motor, it is also constructionally and functionally it is different from the induction motor. There are some differences, so we must know what are those differences. I'm not going to talk much in detail about the working principle and construction and derivations. No, I'm not going to talk about it. Only few basic differences and constructionally how it differs and why these particular methods are used and how it is being done or achieved with respect to the control circuits and logics are how it is being produced. And there are some special purpose relays and switches as well for achieving some applications. Say for example, you have the starting resistance in the wound rotor motor. After a few seconds or something like that, we need to remove them, so we are using some relays for achieving that. And similarly in synchronous motor we have we need to give a DC supply or excitation for for the DC for this synchronous motor for in the rotors. So when we can give this the DC supply, so that we can achieve whether it is over excited or under excited, whatever we need. So when we can give this, so that also determined by some sensors and methods. So we have a different type of sensors in the motor controls. We will see whenever it needs some sensors, we will explain the sensor and then we will explain the operation of that particular motor control circuit. So this is what is a brief introduction about this industrial motor controls. And I'm going to talk about the circuit diagram and control diagram, which will be followed with the NEMA standards. Okay, so I'm not going to follow the IEC standards. I'm going just to follow the NEMA standards. So let us get into the topic. So the first one is uh, you know push buttons are the switches which is used to start and stop the motors. A different type of push buttons are being used with respect to different applications. So the very normal one is normally open push button type and normally closed push button type, which is used for starting the machine and stopping the machine respectively. In some cases we have also have a double acting push buttons where the same push button has NC contacts as well as normally open contacts. So the second one, or this one which you are seeing here, is having both NO contacts as well as NC contacts. So what is NO contact? Without operating the switch or without pressing the switch, normally the contacts, either it is in open condition or it is in closed condition. Electrically these two contacts are isolated or connected. Based on that we can say it is a normally closed or normally open contacts. So when you operate it, the switch position changes. Okay, so this normal, even though it is a normally open push button, when you press or when you operate, these contacts are getting closed so that the electrical current will be allowed to flow through this switch and it reaches to the respective relay coil or to the particular load. Okay, so here in the double acting type, here this normally open contact will be get closed and here it will be get opened. So which terminals are being connected with the circuit, based on that it may work as a switch to break or switch to close the circuit. Okay, so this is a symbolic representation of the push button type switches. So I have a push buttons in my hand. So these are my push button switches where the push buttons are represented with different colors. Okay, so usually the green color push buttons are used for starting the motor or starting the machine, and the red color one is used for stop the machine. Suppose if you have red and green alone in the push button this one package, so you may use a red for green for starting and the red for turn off the machine. In case if you have like this three different colors, so there we can use green for starting, red for emergency stop, and the black one for the normal turn of the machine. So again, these standards may be different with different color codes or different standards. Okay, so this is coming from a particular standard, and it may be different for IEC and IEEE standards and all those things. Okay, so this internal construction, if you see, we have two terminals here. Since it is the first type, we have input side and then output side. So we can give the input at one side and then output will be taken from the other side. So it doesn't have any other function. So if you press the green color switch, so it is a NO type. It is written here. It is written here. You can see it is a NO type. So it is a normally open type switch, and this one is a NC type. So if you see, I have another uh, push button switch box. So where I have the green color push button switch itself having two contacts. One is having NO type and another one is a NC type switch. So here by pressing the single push button, I can close this switch and open this particular switch. Based on your need, you can either use this or use this, or you can use both of them. And similarly, this one is used for turn off the machine. So usually we will use a NC contact or NC switch here. In case if you need NO of this same switch for interlocking purpose or something like that, we can use the NO type here and NC. We have two NCs here. So if you have a double break, so you can use this two NC switches. And similarly, here we have a black color one. So we can use either NC or NO type switches of this. So internally, it is having the construction like this. So we have a input terminal and an output terminal. So these two terminals are stationary or a fixed terminals, and we have a moving terminal or a moving contact which is going to be connected with a spring. So you are going to give a force from here, so which will be acting on the button. So when the button is pressed, so the moving contacts come down and make a electrical contact, so that the electricity will be pass through this switch and it will reach the load for doing some work. So this is in the normal condition, this is in the operated condition. So if you release the hand or if you release the force from the button, then with the help of a spring, it goes back to the normal condition. So in the double acting type, as I told you, we have one NC contact as well as one NO contact. Here in the NC contact, it is always making contact with the this one NC terminals, and here there is no contact until otherwise you operate the switch. So when if you want to use the NC terminal, you will give the supply here and you will take out the supply from here and you will connect the other part of the control circuit. So when you operate this switch, it will break the circuit. In case if you are using NO contact, then when you are operating the switch, then it is going to make the circuit, or it is going to close the circuit, so it is going to start the process. Okay. So in case in some application we will use both of them, one NO and one NC. NO is used to start one particular machine, and the NC is used to interlock the second machine, or second direction. Sometimes forward and reverse will be there. So when you operate in forward, the reverse control circuit ladder should be open, or it should be broken. So for that purpose, we may use both of them to avoid simultaneously both motor getting on, or simultaneously both sequence like forward and reverse getting supply. So for that purpose, mechanically we can give the interlock by having the NC and NO contact. So these also used in many applications in the industrial motor controls. Stacked push buttons, so mostly this is used for emergency stop. So that means any number of rung or ladder may be there in the control circuit. So when you press this emergency stop, everything should be off. It is not like some contactor still getting the power, and some is getting off. No, nothing like that. So everything should go off simultaneously. There is no sequence. Nothing is here. So sometimes the motor is getting stopped in sequence, one first one, second one, third one, like that. But when you press the emergency stop, all the relay coil or contactors will disconnect from the supply, and it will go off immediately. So I have that type of a switch as well here. So this is the one. So if I press this one, it will close, and if you want to turn on, so you will pull it so that it will give the supply to the load. So in emergency case, just need to press like this, so that it will turn off, or it will break the supply to the relay contactor, or to this particular relay, or whatever it is. Okay, so this is about push button that contains multiple contacts, mostly used for emergency stop. So this is what I told you, the push pull button type. So push, push to emergency stop, or push to stop, and pull, little twist and pull to turn on the machine. So this is a push pull type switch. So here it is shown how the push pull type buttons are used. So however, I will talk about these symbols and all those things a little later, because I have not yet done with all this explanation for these symbols. Just we will focus on this area where we are having a push pull type push button. So here, when this push button is pressed down, it is going to make a contact here, so which is going to make the main contactor, or a main contactor to be on. And this main contactor, when it is on, so the contacts will be closed here, the motor will run. When you release the switch from here, immediately it will break the circuit here. Since we don't have any latching here, immediately the main contactor is get de-energized, and because of that, what happens here, this main contactor contacts will open, and the motor will go off. So this kind of circuit, we are using it for inching or jogging. Okay, and if you pull up the switch, what happens here, the contact will close here. So because of this contact is getting closed, the contact, this relay, control relay, is going to get energized. When this is getting energized, so it is going to latch through auxiliary contacts here. So this CR contact will close, also here this CR contact will close here. Even if you release from here, because of this latching, so the C contract relay, the control relay, is going to continuously get the power. Because of this power availability, here this main contactor is also in on condition itself, because you see here this contact relay, we are a control relay, we have a latch here also. So because of this latch, the main contactor is going to be in on, and this is going to close this contact, and the motor will be keep running until otherwise you press the stop push button here. So this type of a switch is for a double purpose. One, if you pull it, it is a normal running condition, but when you press it, so until you press, it will run, and when you release, it will off. So it is used for slow movement or inching or jogging. Okay, so this is used for push pull type applications. The next one is about limit switches, mostly used in conveyor controls and cylinder movements in some actions like hydraulic presses and pneumatic presses and so many other applications as well. So the electrical limit switches are placed at one particular point where you need to stop the particular operation. Sometimes pick and place type of robots, you need to achieve 180-degree rotation or 70-degree rotation. So you can fix the limit switch when the arm rotates and keep close that particular area, then it gives a signal back to the particular control signal, and it either it breaks or close the circuit, so the operation stops there. So that is one important application of this limit switches. Conveyor controls, of course, we have many stations, so that maybe like water filling applications and all those things. So each station we can use one limit switches so that the conveyor will be stopped at that particular point, and once the filling is up, finished, then again with the help of another sensor, the conveyor can run. So these switches used to control the many applications, like as I told you earlier. So apart from that, there are many other sensors and switches. We will see few of them later. So now we will see only the symbols. So we have a float switches, mostly used in liquid level monitoring and all those things, and flow switches. So this flow switches, it also used for the liquid flow or gas flow in a particular direction or in a particular pipe. So it also used to control the action in some of the industrial applications. Pressure switches like compressor, refrigerator, in some other applications as well we use pressure switches. So these switches or the sensors is going to give the input for turn on or turn off the machine. So that is why we are going through this all the symbols for these switches. And temperature switches, it is also used for many operations, like same, like for example, if you have a refrigerator or air conditioner in your home or industrial process, particular temperature when it reaches, it has to open and close the process. Or like industrial areas like transformer heating, and many applications for the temperature sensors as well. So this is a symbol for temperature switches. Contactors and contact. So contactors are represented as a here represented here. So the coil is represented with a circle with the two lines in both end. Okay, and the contacts are represented like a like this. Okay, so it is represented like a capacitor, open contact as well as closed contact, normally closed and normally open contact. So the same symbol is used in PLCs as well to build the ladder logic. Okay, and apart from the normal contactor, we have a timed contactor. So we have on delay timers, off delay timers, retentive timers. So there are many different type of timers as well available. So basically we have on delay timer and off delay timer. So the symbols are represented here. So on delay timer with NO contact and NC contact, and here off delay timer with NO contact and NC contact. So this on delay timer in the beginning of process, if you want to start a motor after few seconds, say for example, if you want to cut some metal. So first 5 minutes or 2 minutes, you need to put a lubricant. After that, after cooling that particular area, then you will start the cutting machine or cutting operation. So something like that. Some many sequences are there like this. First, you need to cool down or you need to bring that particular situation. Then later you will switch on the second one. Or in the star delta starting, you will have the motor start in the star, and after a few seconds or a particular duration, it goes to delta connection. So timing, we need to have timing process in many applications. So based on the requirement, we can use this on delay timer. And sometimes like for example, your CPU, your return of the CPU, but the fan will keep running. Okay, so because it needs to cool down the processor, so after a few seconds or a few minutes, then automatically the fan also will go off. So the off delay timer can be used for this kind of application. So the main operation is done, but it has to cool down the process, or it has to do some particular work, and later like a cleaning work or something like that, later then that particular machine or the motor also will go off. So that kind of application we can use a off delay timer. So these are the symbols. And apart from that, we have many symbols here. So this is what actually the symbols I have shown you earlier. So we have float liquid level, temperature activated switch, flow switches, and vacuum or pressure switches. And apart from that, we have here normal disconnect type of contactors or relays, and circuit interrupters are represented like this: circuit breaker with a thermal overload relay, circuit breakers with magnetic overload relay, and then we are having circuit breaker with a thermal and a magnetic both. So there are different type of circuit breakers, and so the limit switches, normally open, normally closed, the foot switches. In some application, we use foot sensors, like in, for example, in the CNC machine also we have sometimes the foot controls. So many applications we have foot sensors as well, by operating the foot and the two push buttons, something like that, so that you provide more safety for that particular operation. Foot sensors, and so our switches, symbols. And apart from that, a normal SPST switch with a single break, and it is for a double break. And SPST NC type, it is a single break, and here it is double break. So double break in the sense both contact will be isolated, and a single break is only one contact will be isolated from the supply, and the another contact still it is in the with connected to the supply. And SPDT, single pole double throw. So when you not operate, these two contacts are getting closed, and when you operate this switch, then the open type contact will be getting closed. So it is a single break, and then it is about double break. So when you operate this, these two contacts will be connected to the source, and when you not operate the switch, these two contacts in the top, these two contacts will be connected to the circuit. And apart from that, we have a DPST, double pole single throw. We have a single break as well as double break. So where some places we need to isolate both line and neutral. So these are maybe mostly used for like a single phase loads like AC, water heater kind of things, and a single double break also available. Both you know um, terminals, that is input terminal and output terminals, will be isolated. And DPST NC type also available here, and DPDT, double pole double throw. So these type of switches also available in the market. So based on the application, we can use these different switches for different applications. Overload relays, thermal as well as magnetic, two different type of overload relays are in use. This overload relay, this is a thermal one, so where you will have a bimetallic strip or something like that inside. So the heating element will raise the temperature with respect to the load current. When the load current reaches particular value, then the bimetallic strip will actuate this overload relay. In the other hand, when you have a magnetic overload relays, you will have a coil which will produce a magnetic field, and with respect to the magnetic you know um, field which is produced here, and also you may have a delay circuit, like a timing circuit, because magnetic circuit may be, if you not have a delay here, then it will be like a circuit breakers. Okay, so the overload relays are different from the circuit breaker, because circuit breakers are instantaneous tripping device. When it reaches to particular value, immediately it will trip. But in overload relay, that is not the situation. But it needs to tolerate that overload current to certain time. After that only it will release the contact. So especially for the motor controls, it has to withstand for certain time the excess current. Later it will open. If it's sustained for long time, then it will open based on the amount of current. And we have a different type of motor representation. So this is a single phase motor, AC motor, and then we have here three phase AC motor. Of course, we have a different types. Okay, three wire configuration, six wire configuration, four wire configuration. So I just show you a basic thing here. It is a three wire configuration and wound rotor with three wire configuration. So either the stator will be connected as a star or delta, and then here we have rotor terminals which is available here. So sometimes it is connected with external resistance, or sometimes it is connected with different mechanism to starting or speed control. So we can connect a speed controlling resistors. So based on the applications, these terminals are being used. And the transformer, this is air core transformer and this is current transformer. So these are the symbols mostly used in a motor controls. Maybe I am a bit quick, but our focus is not only this. We need to learn more about the motor controls. I just want to give a small review about the symbols which is being used, and their a little purpose also I have explained. You can go through certain sites where you will have a more detail about this, and some books also. It can help you to understand the symbols and standards. Hope you understood this. From the next video we will see the components which we are going to use in the industrial motor controls. Thank you for watching.